Sketch the graph of y equals secant of 2 times x minus pi over 4. To use transformation to sketch this graph, we need to know the graph of the original function secant of x. The graph of secant of x has a period of 2 pi. Going from 0 to 2 pi, there is a vertical asymptote at pi over 2. This is for the graph of secant of x, and at 3 pi over 2, x equals 3 pi over 2. The graph of secant lies above 1 in the first interval from 0 to pi over 2, and then below -1 from pi over 2 to 3 pi over 2, and then above 1 from 3 pi over 2 to 2 pi. When we graph the given function with these transformations, we have to keep this in mind. There is no vertical shift in this case, or there's no vertical stretching or compressing, so we know that the graph of this function will be above y equals 1 and below y equals -1 in the appropriate interval. There are two vertical asymptotes between 0 to 2 pi. Even though there are vertical asymptotes in there, one complete period of secant is 2 pi, and so we let the input of this function, 2 times x minus pi over 4, varies between 0 and 2 pi. The endpoints are included. Remember that we cannot include pi over 2 and 3 pi over 2 inside of the one complete period. Isolate x, we first divide by 2 to all parts of these inequalities to get 0 less than x minus pi over 4 less than or equal to pi. And then we add pi over 4 to all parts. Add pi over 4 in the middle, add pi over 4 in the first part, and add pi over 4 in the last part. 0 plus pi over 4 is pi over 4. The middle part is now x by itself, and the last part is 5 pi over 4. The period of this function is 5 pi over 4 minus pi over 4, which is 4 pi over 4, or pi. We could have gotten the same period if we take the period of secant, which is 2 pi, divided by the coefficient in front of x inside of the secant function, which is 2. 2 pi divided by 2 is pi, and that is the period. But we needed to isolate x in this case because we want to know where the complete cycle of this function starts. It starts at pi over 4 and it ends at 5 pi over 4. Keep in mind the transformation. We set out to put in the x and the y coordinate system. Remember that we start at pi over 4. That would be the start of the cycle. Another pi over 4 is 2 pi over 4, which is pi over 2. Another, we see 3 pi over 4. Another pi over 4 is 4 pi over 4. And the last one, 5 pi over 4. Keep in mind that this complete cycle starts from pi over 4, not 0. From the graph of the original secant of x, we see that after we start at pi over 4, there is a vertical asymptote at pi over 2. And so we put in the vertical asymptote x equals pi over 2, skip 1, and there is another vertical asymptote, in this case, at pi. And so we draw the vertical asymptote x equals pi. Remember that there's no vertical stretching or shrinking or shifting, and so we start the graph at pi over 4, sitting above y equals 1. Follow the vertical asymptote, and then from pi over 2 to pi, the graph lies below -1, and so we sketch the original graph corresponding to the new interval, and then in the last quarter the graph lies above y equals 1. This is the graph of one complete cycle of the given function.